Okay, so picking up where part 1 left off, it only lets me record 15 minutes at a time, so that's why you have 2 recordings. So we're going to find n, or the number of payment periods with the future value known. So how long will it take for $200 deposited at the end of each quarter to amount to $5,726.70 if interest is 6% per annum compounded monthly? So everything we know in this question, the future value is $5,726.70, again with a negative. Okay. Your payments are $200. Your nominal interest rate is 6% or 0.06. And your number of payment periods per year, you're paying at the end of each quarter, which means number of payment periods is 4. And your number of interest periods per year, interest is compounded monthly. So your number of interest periods is 12. So again, that calculates the ratio, the periodic interest rate, and the equivalent rate of interest automatically using these inputs. And I know I'm saying this over and over and over. The reason it's automatic is because I've used the same formulas that I did in the first example for finding a present value all the way up here at the top. Okay. So if we scroll back down, our last item to calculate is the number of payment periods. Again, equals NPER, bracket. We start with our rate, which again is our equivalent rate, not the periodic interest rate. We select our payment next, $200. We don't know the present value, it's what it's asking for, so we type in 0. Now we do know the future value, the next variable it asks for. So you select that cell, comma. And again, just like all these examples, ordinary general annuity, meaning it's the end of the period, so we type in 0. Okay. Our next examples, the last two for this lesson are to find I. Okay, so first let's start with I knowing the present value. All right. So a loan of $6,000 is paid off over 5 years by monthly payments of $120.23. What is the nominal rate of interest on the loan if interest is compounded quarterly? Okay, there's one tweak that you're going to see for this question, okay, and you'll see it when I actually solve the problem. So the first item here, okay, is we know the present value. It's a loan of $6,000, so negative 6,000. Our payments are $120.23. Our number of payment periods per year, okay, it's monthly payments in the question, so that means 12 for our number of payment periods. Interest is compounded quarterly, so our interest periods per year is 4. So again, our ratio was calculated automatically. Our length of investment in years, okay, was given in the question as 5 years. So that means our equivalent, our number of payment periods is actually 60. So what this calculates is actually P, right? It actually calculates the equivalent rate of interest because this is an ordinary general annuity. And remember, in every other example here, the value we used was the equivalent rate of interest, not the periodic rate of interest. So this actually solves for our equivalent rate of interest per period. So this is where it gets a little bit different, okay? So we solved for P, okay? And remember that P is equal to 1 plus your periodic interest rate to the exponent C minus 1. Okay, so we need to figure out what this I value is, and we know P, and now we know C, okay, after doing this calculation. So if you remember, if we're trying to get rid of something that's sitting up here when in the root, there's 2 ways. The easiest way is actually to use the root. Okay, so if you remember, a root, in this case, a square root of something, A, if it's a square root, that's actually equal to A to the exponent 1 divided by whatever order this root is. If it's a square root, that means it's order 2. So it's actually equal to A, whatever's under the square root sign, to the exponent, in this case, 1 divided by 2. In a general example, we'd have the nth root, square root A, that's equal to a to the exponent 1 over n. Okay, so I'm going to use this to show you how to solve for I, and then what we're going to do is put that formula in here to solve for the periodic interest rate. Okay, so first we need this variable 1 plus I to the exponent c on its own. So we have to remove this minus 1 from the right side. So I'm going to add 1 to both sides. Okay, so we're left with 1 plus p equals 1 plus I all to the exponent c. Okay, now what I'm going to do is I'm going to take the root to the order of c, whatever that ratio is, okay, of both sides. Okay, now remember, if I use this general formula, what that means is I can write this as 1 plus p to the exponent 1 divided by c, and that's equal to 1 plus I to the exponent c, right? That's exactly what's under the root sign, divided by c, okay? All I did was apply this rule to both sides of the equation. So these c's will cancel and just become 1. So anything to the exponent 1 is just itself. So what you're left with is 1 plus p to the exponent 1 divided by c is equal to 1 plus I. So lastly, to solve for I, we have to subtract 1 from both sides. Okay, so these ones will cancel, and I'm just going to rearrange to have I is equal to 1 plus p to the exponent 1 divided by c minus 1. Okay, I don't expect you to be able to derive this formula. Okay, I'm just showing you how I arrived at it in order to place it in Excel. All right, so knowing that formula, we can then place it for periodic interest rate here. Okay, so if we do that, I'm going to do equals bracket 1 plus p, which we know is this value, the exponent, okay? And just to make sure order of operations work, I'm going to do the exponent as brackets. So bracket 1 divided by our ratio c, and bracket minus 1. Okay, so all I did was input this formula into Excel exactly the way it looks. If you do that, all right, you arrive at a periodic interest rate, I. And then from that, we can do the nominal interest rate. Okay, so remember the nominal interest rate. So the periodic interest rate is equal to the nominal interest rate divided by m. So if we want to solve for the nominal interest rate, we have to remove m from the right side. So we multiply both sides by m. So our nominal interest rate is just equal to m multiplied by I, or a number of interest compounding periods multiplied by the periodic interest rate. So that's going to equal a periodic interest rate multiplied by the number of interest periods per year. Okay, and we arrive at our nominal interest rate. Okay, so again, I've inputted those formulas in. I encourage you to walk through your questions in Excel, actually looking at this to see if you can get a better understanding. So our last example is to find I knowing the future value. Okay, so our future value, or compute the nominal rate of interest compounded annually, at which $100 deposited at the end of each month for 10 years will amount to $15,000. So our future value, we know, is 15,000, so negative 15,000. Our payments are $100. Our number of payment periods per year, it says, okay, that $100 deposited at the end of each month, which means monthly, so 12. Interest is compounded annually here, so that means our interest periods per year is 1, right? So our ratio was calculated automatically, but our length of investment, again, given in question, 10 years. So that calculates our number of payment periods. Remember, 10 years times 12 payments per year is 120. So now, okay, to find your interest rate, equals rate, okay? So our number of periods is provided here, 120. Our payment, okay, $100. Our present value, we don't know, okay, so that's 0. Our future value, we do know, okay, so select that, negative 15,000. Our type, it's at the end of the period. It's an ordinary general annuity, so type is just 0, okay? And the last item is if you have a guess. In this case, we don't. You only use those if you have ones that might have large iterations so that Excel doesn't come back with an error, so 0. Okay, and it comes up with an equivalent rate of interest. And remember, that's per period, right? And the reason it's per period is because we're finding an ordinary general annuity. So in order to find the periodic interest rate, remember, you have to input this formula, okay, in to the periodic interest rate. You can see that I've inputted it up here in order to find the periodic interest rate. And the last item was a formula I didn't leave. Remember, nominal interest rate is your periodic interest rate times your number of interest compounding periods per year. So that equals your periodic interest rate times your number of interest periods per year. Okay, in this instance, 1, and you arrive at the same nominal interest rate as the periodic interest rate, which makes sense because it's annual. So that was all the examples I had for you. Your assignment will look very similar to this. I do remember, I encourage you, you have to put all of your inputs, you have to make it look neat and professional, and you have to make sure it's your own work. Okay, so this spreadsheet has to be done by you. It's not to be done in groups. You can certainly work with somebody to help you through it, but you have to submit a spreadsheet that's your own. So if you do have any questions on this, please send me an email. I'm happy to answer questions, or you can ask it in our tutorial. Okay, so thanks everybody.